Hi, and welcome to the wonderful world of the scientific hypothesis. My name is Brad Alger. You know, as citizens, we're increasingly bombarded with scientific reports of all kinds, and we're supposed to make sense of them somehow, but we've never really been trained how to do that. So I've created a series of short videos to help you understand some of the fundamental concepts in science. The videos actually are intended to fill in gaps for everyone, scientists as well as non-scientists. Each video lasts from 4 to 9 minutes and covers the important points of a single topic. It's illustrated with simple, non-technical examples. You don't have to be a scientist to follow them. An illustration of the kinds of topics I'm going to go into would address questions like these. For instance, have you ever wondered what a scientific hypothesis really is? An educated guess? Okay, but a guess about what? And are all educated guesses hypotheses? And why are scientists guessing anyway? Do you have to have a hypothesis in order to do science? Or how about this one? If all scientific facts fall short of being 100% definitely true, does that mean science is just random and unreliable? As a professor at the University of Maryland School of Medicine for about 40 years, I led a research group, we did experiments, published papers, got grants, and I taught medical and graduate students. And along the way, I realized there's an awful lot about scientific thinking and reasoning that we take for granted. Numerous key issues are left unaddressed, with the result that lots of advanced science students and even some of my professional colleagues are really quite hazy about the details. So the premise of this series, as I'll explain, is that if you really want to understand science, what it's all about and how it works, the scientific hypothesis is the single most influential concept that you'll encounter, and it's a big one. It touches on a multitude of others. Now, some of you might already be asking, what about theories? What about laws? Aren't they important too? Let me start off by showing you why I've chosen to focus on the hypothesis rather than some of those other ideas. So what about theories and laws? The problem for our purposes is that the terms are used inconsistently across science, and there really are no firm definitions of them. And this is in contrast to the kinds of general principles we'd like to talk about. I'll give some examples using theories. I could do the same with laws. Let's start with a famous theory that about 66 million years ago, an asteroid crashed into the Earth, creating enormous environmental disruption, sent clouds of smoke into the air that obscured the sun for a number of years, triggered volcano activity and acid rain, and led to the extinction of the dinosaurs. Now, this theory has been under investigation for about 40 years. It's enormously well supported by data. You might ask, what is the name of this theory? And you find that it's called the Alvarez hypothesis of dinosaur extinction, after the Alvarez father and son team who invented it. If we jump to the other end of sciences, to social sciences, particularly psychology and sociology, we find that in contrast there's an enormous profusion of theories, and that theories are announced all the time, sometimes it seems with the very first paper on a given topic. And these theories are in general much less well supported by rigorous quantitative data than we find in other sciences. If we go to neuroscience, which is a study of the nervous system and the control of behavior, this is a field that has been under development for over 100 years. There are many phenomena that are extremely well understood, even down to the molecular level, and yet, surprisingly, there really are no theories in neuroscience. One doesn't find the word in neuroscience papers or even in famous textbooks on the subject. If we then go to the queen of sciences, to physics, we find there's an extremely well-supported, very quantitative, very rigorous theory that explains 3 of the 4 known forces of nature, that accounts for all of the subatomic particles and their interactions and the forces that influence them. It is unquestionably the most rigorous and precise theory that has ever been created by the human mind. And so you say, what is the name of this theory, you find it is the Standard Model of particle physics. And so the problem is that theory is not used, as you can see here, at all consistently in these different sciences, whereas we find that the word hypothesis is fairly consistently used in different branches of science. If you go to any one of these fields with the term hypothesis, it means pretty much the same thing in all of them. The other reason for not singling out theories and laws for special treatment is that they have many similarities with hypotheses. All of these things, for example, are tentative explanations for some aspect of nature. They all attempt to account for why things are as they are. They all make testable predictions, and they can all be falsified, though not proven to be true. And so if we look at this, we see that in fact there is one general kind of organizing principle, and I suggest that the word hypothesis captures the important concepts. Now, notice also from this slide a number of the other ideas that we'll have to cover. For instance, we'll have to learn about explanations and testability and predictions and the idea of falsification. In fact, the concept of hypothesis encompasses so many things that I've written a book about it. This one, it's called Defense of the Scientific Hypothesis from Reproducibility Crisis to Big Data. It was published by Oxford University Press, and if you're interested, you can get a copy from Amazon or Oxford or anywhere books are sold. The book covers a lot of ground, and if you have a question about any aspect of scientific thinking, there's a good chance you'll find an answer to it in here. Topics range from philosophical background matters to the hypothesis today, to different kinds of science, those that use hypotheses and those that don't. It goes into different kinds of hypotheses as well, and evaluates the role of the hypothesis in major scientific issues that we don't normally associate with it, like the reproducibility crisis of science. The book discusses many advantages of the hypothesis and reports on surveys of how scientists use hypotheses in their own work. And there's much more besides, including opposing arguments that science no longer needs a hypothesis and should abandon it. The book goes into the hypothesis in everyday life, in education, and in the big data science of the future. So that's it. The videos are mainly based on topics from the book. If you have a question and post it, I'll try to answer it. And if you still want more, there's always the book itself. If you want to be notified when a new video posts, you can just hit the subscribe button in the corner. In the next video, I'll start with the foundational concepts of hypothesis and prediction. These two central and powerful ideas often trip people up, but they'll come up frequently throughout the series. You'll find that once you get them down pat, a lot of more complicated issues will be much easier to follow. Thanks for watching. Remember to give it a thumbs up if you like it and subscribe to hear more. See you next time.